what I'd like to do now is have one of our, two of our experts come up, and I won't go to that one. The first person that I'd like to introduce is Graham Whyte, who's here today with us to talk about floating production. He's the Floating Production Unit Automation Team Leader from Chevron, and he is our first speaker. And also he is going to speak with Pham, who is the Process Control System Team Lead from Chevron. So
Good morning. Can everyone hear me?
He's going to, let me put this on.
Is working here. Well, perhaps I'll resort to the backup mic. Is that a bit better? Can you hear me up the back? Janice, I think that's better. Now we've got some sound. Well, thank you very much for coming along to our presentation this morning. My name's Graham Whyte, as Janice said. I'm the automation team leader with Chevron's deep water exploration and major capital projects in Houston. And I've been fortunate to spend the last 6 years as the automation team leader on one of our flagship major capital projects in the Gulf of Mexico, and that's really the focus of our talk this morning, where you see a slide of the actual facility currently producing out in the Gulf of Mexico, approximately 270 miles south of New Orleans. But like all these things, it's all about teamwork. So we have Pham here from the Chevron Energy Technology Company this morning, who will be participating in the presentation. So I'll just ask to step forward and say a few words.
Can y'all hear me? Oh, I don't know. I'll turn this on.
We've got the backup technology.
Yeah.
Testing. Can you hear me? Yeah. Okay, good morning. My name is Pham. I'm a team lead in Chevron Technology Company. And in my team, we responsible for all the control systems. So that could be any DCS, SCADA, POC, the whole control system. So with that, you want to start the presentation?
Thank you. Yeah. So what I'd like to do is I'd like to talk a little bit about the agenda this morning. So I'm going to give you an overview of the Jack and St. Malo facility, and then what we're going to do is we're going to talk about Chevron's overall vision for what we term the EAS, the Enterprise Automation Solution. And then I'm going to talk about the pilot project that basically Jack and St. Malo was able to incorporate into our overall major capital project execution for the JSM project. And there's some benefits and really test results and lessons learned. So with that, I'd like to talk a little bit about the Jack and St. Malo project in detail. So location, as I said, it's actually in the Walker Ridge block of the Gulf of Mexico, which is about approximately 270 miles south of New Orleans. The water depth there is approximately 7,000 feet. So we have a floating production moored semi-submersible unit, and basically it's one of the largest deep draft semi-submersible facilities in the world at this time. And the nameplate production for what we call stage 1 production is going to be approximately 170,000 barrels of oil per day. We achieved first oil production on December the 1st of last year. And my particular involvement in the project has been some 6 years now. So I've seen the project evolve from essentially a 3D PDMS model and reference architectures to actually been involved in the commissioning activities supporting first oil offshore last year. The actual development, there are two subsea fields, the Jack field and the St. Malo field, and basically the two fields, the two subsea completions, are tied back to a central host. The fields are actually 30 miles apart, and the host itself is equidistant between those two fields. A lot of technical innovation, lot of technical challenges and innovation to solve those challenges within the scope of the project. This was one of the first, one of Chevron's first developments in what is called the Wilcox Tertiary region. Now, I'm not a subsurface engineer, so I don't really have too much in the way of expertise to talk about that, but the Wilcox Tertiary region represents this large reserve of oil which is actually below this salt dome, and it's extremely difficult to get reliable seismic data back to the reservoir and geologists for that. So Chevron pioneered a lot of new technology in terms of improving the quality of that seismic data in the evaluation of the field. A lot of other firsts in the project. It's one of the largest subsea pipelines in the Gulf of Mexico at that depth, and we have other technology innovations such as the seafloor boosting equipment. So we have 3.5 to 4 megawatt submersible pumps down on the seafloor to assist with basically the recovery of the fluids. I could actually talk about those details of the project for quite some time, and that's not really the focus of the presentation this morning. But I will give a shameless plug for Penwell's Offshore magazine here. Basically, the project made the front page of the January edition. Very proud, that we've been acknowledged. And this magazine has a very detailed article inside, and it also has an extremely upbeat and optimistic outlook for the Gulf of Mexico in general as a major oil-producing region, deep water. This magazine is available out in the foyer, and I would encourage anyone in the room that has an interest in reading a little bit more about the project and the challenges that we had, to pick up a copy of it. So anyway, that's my plug for Penwell. So moving on to really what is the focus of our presentation today, we have what we call our PAS, our Process Automation System on board, and this comprises a fully integrated system, and from a PCS, a process control perspective, we have Yokogawa's Centum VP DCS system on board, and that's integrated with Yokogawa's ProSafe RS safety system. So we have a very, very tight, close integration between basically our safety and process control. We bought, in common with a lot of offshore projects, a lot of equipment is packaged. So power generation, compression, metering, many of the support systems that go together to basically support the oil production. So we standardized on Rockwell's ControlLogix platform for those third-party package systems, and we integrate those third-party package systems into the Yokogawa system as part of our overall integrated operations. A couple of other equipment packages down there. The power generation on the facility currently is provided by a total of 3 General Electric LM2500 G4 pluses. So each of those generators has an output of approximately 26 megawatts, and we have a further 2 generators in scope for what we call future development. So and just kind of closing out on some of the other in-scope items for our automation solution, we have a Schweitzer Engineering Laboratories power management system. So we have a very, very complicated electrical system on board because we're driving these submersible subsea pumps. So we have a very sophisticated power management system. Again, power management system is integrated into the overall control system architecture. So from a control room perspective, the entire visualization of the facilities on the platform is through our Yokogawa system and on our graphics. Subsea-wise, the project was the project control system was from Cameron Subsea, now integrated as a number of companies under the banner of what's called One Subsea, including Pham and other subsea companies. So just forward here. So this is a little bit of a blurry cartoon, and this really, the intent here is to basically convey the size of the system. So we've got all of our central control room. So on the right here we see basically an image of our central control room. This is the main operations centre on the facility for both marine operations, because don't forget we're on board a semi-submersible production unit. So we've got marine systems, we've got hydrocarbon systems, we've got utility systems, and the operation of all those systems is all integrated from this central control room. What you'll find is that there are no third-party interface products in that control room. So the operators visualize the entire process production system, marine operations and subsea through the Yokogawa interface. That helps us and gives us a lot of advantages in terms of how we handle alarms. It provides us with a consistent approach to our alarm handling. So in terms of the size of the system, and I'll just kind of skip down here a little bit, we have 45 redundant safety controllers. So the redundancy gives us a high availability, and this is coupled together with a total of 21 field control stations. So from a hardware perspective, we have a total of 86 HP G8 servers on board. These run a number of functions such as the operator graphics, our data historian, application servers, antivirus and patch management, and that really totals up operator training simulator. So that really basically gives us this quite high number here. So we've got all these IT assets now essentially that we need to take care of, and along with that comes the issue of PCN security and IP, etc., which has been a big focus for the conference this week. In terms of physical devices, we've got like 10,000 physical instruments on the facility. That's both associated with the marine hull and the topside hydrocarbon processing systems. And substantially for our process control, we're leveraging basically the foundation field bus solution, where essentially we've got a bus-based system for our intelligent instruments, which give us a lot of data back, which then feed into our asset management portfolio. And we're going to come on to why that's important in a minute from a big data perspective. And as I mentioned before, full data integration with all of our external systems. Back in the early part of my career, I would work on different facilities where there was minimal integration, and operators would be challenged to move from different HMI packages that were supporting different functions in the control room. And alarm management, graphics were all presented quite differently according to which system you went to. So you needed some pretty good operators to be able to navigate around that. So the purpose of integration here is to make sure that we present unified information to the facility, and our operators are well set to actually operate and control the facility in a safe and reliable manner. So with that said, that's really a bit of background on the project and my role. As always, success is all based, in my opinion, on a team effort, and my passion's around the development of high-performing teams in order to meet those goals and deliverables, and that's certainly been the case on Jack and St Malo. And whilst they're not here today, I would like to acknowledge the excellent work done by the automation team on the project, which help immensely leverage our success and help us achieve first oil, as I mentioned last year. But it doesn't end there. You know, we have partners. We have basically the Chevron Engineering Energy Technology Company providing us with capital stewardship and guidance on Chevron's global engineering standards and you know, initiatives. But yesterday, I want to mention another company, as it were. Yesterday, I went to a presentation, and one of the slides that the presenter put up talked about current vision, you know, current status versus you know, future state. And what they did was that they listed down, one of the attributes was vendors. So they kind of characterised suppliers as vendors in the current state, and then the future state was shown to be partnerships. And that's where I'd really like to acknowledge Yokogawa here, who truly is Chevron's technical partner. And so I think from the perspective of the presentation I saw yesterday, that, you know, Chevron in that context is already in that future state. So I very much appreciate all of the work done by Yokogawa Corporation to basically support the project and also develop the solutions to some of these technical problems and challenges that we're going to talk about today. But what I'd like to do now is I'd like to hand it over to Wee, because Wee's going to basically talk about Chevron's EAS vision from a corporate perspective.
Thanks, Graham. All right, so before I connect the dot between what we're doing and the enterprise manufacturing intelligence, I want to set kind of a basis. So JSM is one of our larger, probably the largest, not sure, offshore facility. But you imagine the asset that Chevron have. I don't know the count in Gulf of Mexico. Offshore Angola, we have over 125 offshore facilities. Okay. This better? Yeah, much better. So repeating, offshore Angola, we have over 125 facilities. On North America, onshore, got in the neighborhood 3,000 to 5,000 wells. So it's a vast amount of facility globally. So we set that basis. I'm going to try to connect the dot, right? So within starting more than 15 years ago, Chevron started multiple initiatives, and all these tie up. The starting initiative is this little word here, down here, called Oilfield. Oilfield in Chevron is initiative of, I would call it digital oil field. How do we digitize the oil field? Because with the long history of Chevron, we do have asset out there that we can't get data from. Everything is local. So how do we digitize all those data? So that's one initiative that started maybe 15 years ago. Right. Thinking maybe around 5 to 6 years ago, Chevron started another initiative, and we call that Upstream Workflow Transformation. Is imagine if you have these data, how do you create values? How can you commoditize these data, right? And so the UWT, in short, initiative got kicked off. And what you see up here is the vision for the UWT initiative. The very basic one is, okay, now that we have the data, how do we set up for surveillance and data capabilities? And then the next step is, okay, let's create automated, standardized workflow for these and make use of these data, right? And then once we do this and we standardize this, we want to push it out to different business units globally. So imagine this, we have a common workflow, automated workflow that any business can use, and it's all standardized. So you go from Nigeria to Indonesia, back Houston, it's the same workflow. So once we have that workflow in place, right, we can start the last bullet item, which is we can start collaborating, cross-functional, cross-organization. It doesn't matter where you are globally. Right? So that's the vision of UWT. Okay. So how is UWT fit in process automation? So we know from these vision what automation, what are the criteria, right? So one is, okay, remote operation. So what do we need, what's the boundary of remote operation? Things like, do we need remote monitoring and control? Single HMI, right? And so forth. Be able to do alarms. And also, this one of the big criteria is low bandwidth and high latency. Because imagine all the facility offshore, not every facility have fiber optics. Some satellite, some microwave, all sort of communication equipment. Also, one criteria, enterprise integration. So it have to support web-based platform, dashboard view, KPIs. It have to be on a mobile platforms, right? And then, of course, another criteria we want to have is remote engineering. Be able to engineer systems remotely, right? Imagine the challenge because of that and with the low bandwidth. Okay, so I talk about iField, I talk about UWT. So within process automation, we say, okay, how do we get from iField to UWT? Right, so we look, what's the infrastructure? So that's where EAS come about. We call it Enterprise Automation Solution. It's connecting from the iField, which is, we got data from all the way from reservoir up to facility, and now multiply number of facility across globally. Big data, right? But we go beyond that. We want to be able to be seamlessly integrated. That means all the way from the field where it's a plug-and-play device, easy, single source of data, all the way up to enterprise. We do not want to re-engineer, right? So once you get up here, that's where the UWT environment. Within UWT, we see, okay, we can use the data for decision support center. And that's, we have multiple type of decision support center. We have rotating equipment, we have well optimization, so it's limitless, right? We also have what we call integrated operation center. And then we also have collaboration center. And that is to connect the field to a subject matter expert that could be located halfway around the world, right? So each of this initiative have a roadmap. So for example, if I talk about IOC, right? So if we get data in there, our roadmap is the first level would be surveillance. That's given. So once we get surveillance, what's the next step? It's analytic. And then after analytic is, okay, we're ready for doing optimization. So each of this UWT workflow have its own roadmap. Right. So with EAS, so we started EAS 4 or 5 years ago, and with our preferred alliances, our partner, Yokogawa, we embark on a journey. How do we create this enterprise automation solution? So And we're still on that journey. I consider we're early part in the journey. The solution that we came up with are actually two components. First component is we call it remote gateway station. Is that how do you collect the data from the facility system and bring it to the enterprise? And the second is the HMI web server. So once you get on the enterprise, how do you distribute that out? And all these have to also be secure and low bandwidth, and we have a bunch of criteria, right? So these are the solutions. It have to be HTML5 web-based. You can see, right? Also, again, the biggest driver for this is we don't want to have an engineered system. We do not want to have system A and then we have to build another database in system B and connect together mapping, because there's too much data. We want our goal is a zero engineering solution, right? So it's automatic conversion if we're going from the facility up to the enterprise. Go through many application solution, it had to be seamless. So the history of our journey with Yokogawa, we had a proof of concept testing almost 4 years ago in one of our facility in Gulf of Thailand. And with recently, let me step back. Within Chevron, any new technology, we have a qualification process, and it's less intense process that we have to go through, starting from research to proof of concept, development, and pilot. So we taking this EAS through that process, and we partner with JSM project to do the pilot on JSM, right? So back up again is what are there are multiple solutions out there, but we also have barriers, and the barrier is low bandwidth, high latency, and we want zero engineering solution, right? So with that, a journey takes us to currently two solutions. One is we call it an enterprise solution, and that is comprised of Yokogawa Fast2, Yokogawa RGS, the remote gateway. And another one that we have criteria in there is how do we do remote engineering through low bandwidth. And that's the solution, Yokogawa solution is called Whyte Area Controller. And basically it extending the control network remotely through low bandwidth connectivity. Okay, so, right, so going back to specific JSM pilot scope, right? So basically, there's a lot of detail, but what we want to do is connect the JSM facility to operations center in Covington, Louisiana, but also have connection to our Houston office. Right. Graham, you want to go into detail with this?
Yeah, thanks for that, Wee. So this is kind of like a basic architecture diagram of the solution that we implemented on the JSM facility. So on the right-hand side, we see the actual facility itself, as mentioned, 270 miles south of New Orleans in the Walker Ridge area of the Gulf of Mexico. And then on the left-hand side, essentially what we've got is our onshore facility. We was talking about basically our integrated operations centres. these are the centres that basically are manned continuously, and what it does, it connects all of our assets back to the shore. So various subject matter experts and management can monitor operations on the facility in real time. So there's really this diagram really illustrates the two parts of the project, or the goals of UWT. So one is the remote connectivity here on the bottom, and then on the top is really our enterprise-wide solution. Both really important requirements that were in scope. So from a what we call the wide area controller perspective, this part of the project implemented our remote operator station connectivity. So we've got a remote operations center back in Covington, Louisiana, and what we need to do is we need to replicate the operator stations that we have offshore on the facility back in the Covington Operations Center. One of the really important operational aspects of having a facility in the Gulf of Mexico is what we call hurricane evacuation. So periodically, the Chevron meteorology people will give the business unit basically a prediction based on a developing weather front, and in particular of interest, the hurricanes. So we continue to monitor, that potential activity, and then maybe up to 48 hours before, if the facility is within the path of, or the predicted path of the hurricane, around about 48 hours or so, what we do, we start to shut in operations, and then we go through a process of essentially evacuating the crew. And we've got about, on the JSM facility itself, operationally, we have a crew of about 60 guys offshore at any one time. So we need to get these people back to the shore. We need to make sure that they're safe. But once the facility, from a hydrocarbons producing perspective, is shut in, we need to continue to maintain surveillance on the facility and other operations, because when we leave the facility, we still have power generation, we have safety systems operable, we have marine systems online, ensuring the stability of the asset. So it's really important that we get these, that we're able to replicate and produce operator interface, and because that becomes the main means for us to monitor and control facilities on the asset. Now, when I talk about remote control and surveillance, this is not from a hydrocarbon producing perspective, because the regulatory body that are responsible for operations in the Gulf of Mexico, they don't currently issue permits to operators to remotely or produce hydrocarbons not for deep water on an unmanned facility. So as we said, there were several solutions from Yokogawa that we could have used, but none of them really met the functional requirements and the security and the integrity requirements that we have for the project. So that's really the development of the wax solution here. And what we do is that we've got our control system network, which is connects all of our Yokogawa equipment together on the facility, and also all of our third-party equipment, like our environmental facilities monitoring system, our load management system, and all of these other systems that are of particular interest when we're in a hurricane evacuation mode. So this basically connects it up through initially what was the low bandwidth satellite communication connection, and this basically transmits the data to our operations center in Covington, Louisiana, where we have essentially our operator stations replicated in our integrated operations center. So this provides us with a lot of rich functionality. It replicates really exactly what we're seeing offshore in terms of our offshore central control system environment. The second part of the upper part of the diagram here This relates to essentially the fast tools aspect of the project. So this is where we get our big data from. This is feeding all of those UwT Oilfield applications. We organise the applications into what we call work streams. So we mentioned a few of them. We've got real-time reservoir monitoring, which is very, very data intensive. We've got basically our rotating equipment decision environment. So we're taking all this continuous online data from our gas turbines, our submersible pumps, and what we're doing is we're pulling all that data to shore, and then we're organising it in a work stream where that work stream is analysed, and we can look at basically and predict the performance of our equipment assets offshore. As I say, plus together the what we call the remote graphics capability. When I first started on the project, as I say, some 6 years ago, one of the production engineers came to my office and he kind of jokingly said, "Well, I want to be able to go to Starbucks on a Sunday morning, like I always do, to read the newspaper. And if I get a call from the operations team offshore requiring some subject matter advice and input, I want to basically be able to pull all that data and graphics up on my smartphone." I kind of looked at him at the time and kind of smiled, and he promptly left my office. So it kind of got us thinking about how we could come up with a solution to do that, because certainly at that time, we really didn't have anything in the portfolio of solutions that would support that. And here's the important thing: in a secure manner. That's the thing. It has to be secure.
Graham, can I add something
sure.
to this?
Come on in, Whyte.
Can you go back to the slide? So you see the Chevron guild. That's the Chevron global network, right? So imagine this. Once we get the data on there, and if they're doing well intervention in Gulf of Mexico, and we have a expert, and we need an expert that resides in Perth, and because of time difference, he may be sitting in a restaurant. We can actually get the information of what they operate in Gulf Mexico Sea on his iPhone, and he'll be on the phone helping Gulf Mexico.
Yeah, and we can certainly do that today. So moving on in the presentation, this was really the remote connectivity. So this is what connects our remote operator stations at our remote operations centre in Covington. And it's the hardware here. It looks the footprint is very, very similar to Yokogawa's field control station, but it has some specific requirements. It has a high level of redundancy, basically, which is always pretty much a requirement. And what it does, it essentially converts Yokogawa's proprietary VNet IP protocol to Ethernet, and this is basically the packet that we send over this low bandwidth satellite. So it supports data caching, and as we keep talking about, it's the low bandwidth network. The low bandwidth network is one issue, but the real issue is latency, and latency is just another word for delay. And the Yokogawa network is designed with a specific protocol. And that protocol, in order to basically maintain a deterministic performance, it expects to see data move in a deterministic manner. And when we get this latency in the system, this delay, this is where basically that network runs into problems. So main thing here is to basically address and essentially take care of the latency issue here. So moving on to the next slide. So really this was a pilot project. So JSM has been running along. We've got all this equipment installed. The actual hull itself was built in Korea, so we had to deliver all of our marine systems prior to the sail away and to support quayside operations here on the Gulf Coast in Ingleside. where basically all of our topside modules were built. So a big exercise around fabric integration. So we've got this corporate initiative where we're looking for solutions to meet the challenges of providing this data in a reliable manner. So again, this is an example of cooperation between major capital projects and basically the technology company and the technology partner with Yokogawa. And Yokogawa allows us to participate in that development to the extent that we actually go and support the testing of those products and solutions at a Yokogawa facility. And that essentially allows both the technology company at Chevron and early adopters such as the major capital projects to really ensure that those products are appropriately tested and that they're really ready for deployment, and it gives us an opportunity as disciplined engineers to also endorse those solutions within and provide that endorsement within what we call our community of practice. So I don't work in a silo in Chevron on deep water major capital projects. I work within a network of other disciplined engineers to make sure that major capital projects across the corporation are always following the best practices and leveraging the best technology for our needs. So in scope for the project was to really evaluate different conditions based on low bandwidth satellite, fiber optic communications, database equalization, very important around engineering functions with respect to and changes with respect to the Yokogawa system. We use an engineering workstation to do that, and the engineering workstation is fully supported via what we call the wide area controller connection, something that we didn't have before. And then really the enterprise automation solution, which is this is where our big data is coming from, is to really look at we made reference to, well, we want all this, but we want it as a byproduct of our configuration work. So what we don't want to do is we don't want to develop our graphics system and our control system database and then take that and then rework that into a format for a SCADA database. So there are a lot of tools that actually help us to do that automatically and in a cost-effective way. So these are just some slides. I'm going to get wrapped up here in a minute. So this is really kind of a bandwidth analyzer that we showed, and we basically pumped all this data across the link, and what we did was we then basically choked the bandwidth of the link to see how basically it would perform. And even with a fairly high latency on the satellite link, we were still achieving a call-up time for our graphics onshore of 2 seconds and a data update of 1 second. So really good, acceptable level of performance there. And it's important that we provide reliable solutions, because if we don't, then the operations people that use these solutions, what happens is that they lose confidence in the solutions, and stuff starts to kind of just collect dust, and it doesn't translate into any value for the company. On this side, what we're seeing here is this is our big data solution. So we've basically got 500,000 tags coming in basically every 6 seconds. So we're going to get basically 5 million tags in a minute, and if we've got basically 10 assets connected over this enterprise, then it's basically 10 times that amount. So we're really getting into the realms of what I'm hearing is big data, and then what we do with that data is addressed in the various work streams that we discussed earlier. This is really our basic graphics conversion. This represents really what our Yokogawa HIS station does in terms of its graphics interface. What we used was the abnormal situation management graphics, AMSM style graphics. So you're not going to see a lot of color here. Operators kind of attention is drawn to the screen by exception. So and then on the bottom here we have our fast tools conversion, which is not another group of people sitting down configuring graphics, is actually an automatic conversion provided by the tool. So benefits of the pilot project, I mean, obviously it allows us to, evaluate the technology in a realistic and real situation. And it certainly produced a solution that addressed the limitations of at that time, the available Yokogawa solutions. And it really serves as groundwork for us to deploy it and provide experience to other major capital projects. So lessons learned, early engagement, as always. Chevron have a lot of very, very rigorous requirements around basically what we call process control network security. So we have to make sure that we can't just go out there and do this science project because it looks fun. We have to make sure that basically all the scope encompasses, the policies and procedures that the corporation deploys worldwide. Life cycle support and deployment. And we need to look at the whole solution. It's not just about individual components. And resources, always, we, as I said, we were engaged in delivering the automation associated with the major capital project. So when this opportunity to do the pilot project came along, we had to bring additional resources in the team, but specifically to execute the EAS and the WAC and the EAS solution. So appreciate the opportunity to kind of share some of our experience with you today. Appreciate your attention and look forward to any questions that you may have in the panel session a little bit later. Thank you.